In this math example, we're going to analytically find all the values of x for which the derivative is equal to 0. So to do that, first thing we need to do is calculate the derivative of this function. Then we're going to set it equal to 0. So first of all, the derivative of this function, we're just going to use the power rule a couple times, go through this one term at a time. Really not that bad to start out. So the derivative of x to the third power, we're going to bring the exponent down in front, then reduce the exponent by 1. So 3 minus 1 gives us 2 for our new exponent. Then kind of repeat this process on the next term. We're going to bring the 2 down in front, multiply it by positive 6, so we're going to get positive 12. Then reduce the exponent by 1. So 2 minus 1 makes 1 for our new exponent. I'm not going to write that 1 up there because it's understood that x is automatically raised to the first power. All right, next we get a linear term. Well, the linear term is just going to be the derivative gets the number out in front. And then what you could do is you do x to the, it was to the first power. When we do 1 minus 1 for our new exponent, we get x to the 0 power, but that's the same thing as 1, so that's why we don't write it next to it. And then finally, we go ahead and we have a constant term, that plus 5. Its derivative is going to be 0. But we don't really need to write a plus 0 at the end, so I'm going to get rid of that part. All right, now that we have the derivative, the next thing we'd like to do is go ahead and figure out when is that going to equal 0. So next step, I'm going to set this derivative equal to 0, and let's think about how do we solve this down. Now we could always pull out the quadratic formula because we now have a quadratic equation. However, I think we may be able to do a little bit of factoring and zero product property to help us out. So the first thing I notice on the left-hand side is all of these terms have a 3 in common. So let's remove that common factor of 3. That's going to leave us with, what, x squared on the inside. And then 3 times 4x makes that middle term. Kind of a big number here, but 3 times negative 96 makes negative 288. All right, from here, again, 96 is a pretty big number, but that's what we want to focus on when we're thinking about how are we going to factor that 96. So listing out all the different ways to factor it, it could be 1 and 96, it could be 2 and 48, 3 works because of course it does, 4 times 24, 5 doesn't work, 6 and 16, or finally 8 and 12. Now we want to pick out the pair that subtracts and gives us a 4 because that's a negative in front of our constant. Well, I think 12 minus 8 is going to make 4. So let's use that as our factors. Okay, so we have 3. This is going to split up as x and x for that x squared term. And then we said we were going to use 8 and 12. We need to make sure that when we subtract these, we get a positive 4 in the middle. So what I'm going to do is go positive 12 minus 8 is going to make that positive 4 in the middle. From here, what remains is really just setting each one of these factors equal to 0. We don't have to worry about that 3 equaling 0 because we don't have a variable with it, and then solve these down. So add 8 to the other side here. Subtract 12 to the other side on this other equation, and those are the values of x that are going to make the derivative equal 0. So I hope this helps out as you're working on analytically finding values for which the derivative equals 0. Just take your derivative using the power rule, then go back to your basics on algebra, or use the quadratic formula. You'll get the exact same solutions. Good luck.